We're good to go.
Okay. So, yeah. I'm just going to take a few different iPhone 6 Plus batteries and show you what the tester does. The tester has regular old USB, micro USB power cord. Micro USB goes into the socket right there. And to start out with, don't even plug it in. Just take a battery, orient it however you like. You can use it this way, or you can use it upside down this way. The battery tabs and connectors should align with where they're supposed to be in either orientation. Just follow what they say. So 6P, 6 Plus says zeros and 3 and about 3/4. This is amperage. This is power going into the battery. And this is voltage read at the battery leads itself. So obviously we're not putting any power in, and the battery is entirely powering this on its own. And we've got about 3 3/4 volts. We're going to plug in our USB to just a desktop computer here and plug in USB power into here. These numbers change. So we've got now 4.13 volts. So that's the 5 volts coming in and the battery voltage combined to be that. So you have a voltage drop from 5 volts or whatever your known voltage is to this voltage. You can calculate a little bit of the draw based on that. And then you can also meter the draw right here, roughly 1 amp going in. I can grab a screwdriver. Just a regular old fine Phillips and of the right size. We can drop the voltage input so it actually regulates from 5 to whatever you want. So we can go down or we can go up in voltage, and this is a rotary adjustment, and it does roll over, so if you go too far it'll go back down again, but we'll put it up to whatever it can go to, which is 4.25. We have another adjustment right here, and this is for the amperage. That's also adjustable, so roughly at 1 amp now, and it can go up reasonably high, and it depends partly on what it's connected to. This is just a desktop computer. In theory it should only be supplying half an amp of power, but as usual they can supply much more. So what we're looking for at this point is, this is the amperage going in, this is the voltage. What will happen as the voltage at the battery increases, so here we disconnect it, we're a little bit higher than we were. This would take normally a couple of hours perhaps, because of the nature of how it's charging it. But yeah, we're a little bit higher. But what will happen when it's entirely topped off is this number over here will just be 0. That means that regardless of how much input current is available, the battery and the circuit that's right down here connecting the actual battery connector here to the cell itself, there's a little circuit in there which is going to regulate what the maximum voltage is. Once it sees that maximum voltage here, it stops. It says, sorry, I'm not taking any more power, and this drops to 0. And then this will read what the true voltage of the battery is at that point. And that will mean that the battery is entirely topped off. So other things can happen too. I'm going to disconnect power. I'm going to disconnect this battery, just using a plastic spudger. It's a pretty safe instrument to use. One of these batteries isn't working right at all. And so now I plug it in and it's extremely dim, 2.64. Most phones wouldn't want to charge this battery. They may show up with the trickle charging, but depending on what type of phone we're talking about, it might not do it at all, and it just turned off. So actually it reached the lower threshold of the battery where it refuses to actually output power. We can plug in power to it, and it's going to take close to 3 amps at 3.37 volts. So this thing is just thirsty. It's absolutely stone dead, and if you notice, it entirely shut off when we were doing that testing. Just because it shuts off does not necessarily mean the battery is bad, but it does mean that the amount of power available is, or rather the amount of power available at the battery is effectively 0, because the battery protection circuit here is refusing to have anything to do with connecting it. So let's disconnect this one and see about the next one. Notice we unplug it, and it's reading the average voltage, and it's floating right around 5 volts, 0 amps. Obviously,
You're good.
so we're going to plug in our third and final battery. align it here. The whole entire tester just went dead. And I think that there might be a short here, or rather an open short, or not. But just to be on the safe side, I'm going to press the battery activation button. This is basically just a measure to bypass the little safety circuit here. And you will want to make sure it's not getting toasty on you. But you're going to bypass that little protection circuit. And the thought there is, of course, if you are really low on power, but you could, charge it if you needed to, but it's below the threshold here, by holding this, you might be able to get it up to a voltage where it'll actually respond normally, and the protection circuit will stop cutting it off. So let's see what it does. Let go, nothing. Press it, nothing. Rock the connector around. Connector's not hot or anything, so we don't have a short there. But yeah, there's just nothing really coming out of it. If we unplug it, we replug it, unplug it, replug it. Nothing at all. Not sure what's going on here. We can disconnect it partly. So maybe we're looking at an issue with the connector of the battery. Nope. There is a really small cut right there. Just a tiny little cut. So this battery charger actually is, in this case, useful for determining that this battery is not going to work. It's probably shorting against something here, one of the grounding areas perhaps. And for that reason, it's protecting itself. So it's got some protection circuitry in it. So you don't need to worry about shorting the battery and damaging it, and you don't need to worry about damaging the tester either. And just to prove that point, let's go back to the first battery that we were charging and plug it in. And again, we're pushing current into it. So just to recap, this is useful if you wanted to charge a battery and see that it takes a charge and goes up to a certain voltage. It's useful for doing that with several batteries. And in fact, I've got, this is the one that doesn't charge, but I can add another one in series onto it, or rather in parallel. And so now we have two batteries sitting on here. And because the protection circuit for each battery is automatically going to stop current flow once it gets up to its fully charged state, we can leave as many batteries plugged into it as you want, and it's really just going to top them off. So if you're going to store these batteries on your shelf and you need to know that when you pull them out of the shelf and you put them into your customer's device, they're going to fire right up because they were fully charged. If you need to know that, and who doesn't, just top off all your batteries on this charger. And if a battery doesn't charge, then you know that that battery isn't actually a good battery, and you need to ship that one back. So you can check for bad batteries too in the process of topping off your other batteries. So really, you do dual duty in making sure that things are ready to go for customer service parts, and also making sure that you are testing and finding the bad parts prior to shipping out. But again, this process does take a while. And this is the battery tester that we have available. Don't have a SKU number offhand, but talk to your sales rep. This is the tool I'd recommend for that kind of testing.
All set?
Mm-hmm.